Okay, you have to excuse the ill-advised title slide. Yeah, I thought of this more as a placeholder. It was a kind of starting point for me to start thinking through exactly what I thought about rhythms, and particularly in relation to my own practice and how that might inform the curatorial approach to the Fluid Rhythms program. And so what I'm really going to do, I think, over the next 20 minutes is give something of a, well, it's going to be like a machine gun, really. I'm going to kind of give you this very fast ride through a lot of sometimes complex, sometimes not so complex ideas. And they're things that are quite large concepts and influences on our studio's work. And I think will help to sort of colour the approach that I've sort of taken to the program. So as Bart kind of introduced already, let's say a big fascination with our studio's work is the microscopic things that we know surround, permeate, and indeed make us, but that typically lie beyond the range of conscious perception. So ruminating on the notion of rhythm, it's actually impossible to avoid the ineffaceable synergy between rhythm and waves. Waves thought of in this case as being effectively the trace of rhythm. So for thousands of years now, astronomy was the province of visible light. As we entered the 20th century, however, astronomers began to study other forms of light, from radio waves to infrared light to gamma rays. More recently, astronomers became interested in the realm of lightless astronomy, the study of gravitational waves. Gravitational waves are an important prediction of Einstein's general theory of relativity. According to this theory, a variety of astronomical objects, such as supernova explosions, pairs of black holes like you see here, and other mutually orbiting objects with strong gravity, they give off an energy as disturbances in the structure of space-time that spread outward at the speed of light. Measuring these waves of energy requires highly sensitive detection equipment. So there's LIGO, which is the Laser Interferometer Gravitational-Wave Observatory, which is located at Louisiana and Washington in the United States. And it's a pair of such devices, constructed to detect gravitational waves produced by supernovae, colliding pulsars and other cataclysmic astronomical events. So that was a bit of a tongue twister, hundreds of millions of light years away. The design of such instrumentation not only makes the detection of this imperceivable phenomena tangible for the first time, but forces us to question the ways in which rhythms permeate and form our very existence. The image that I'm showing here, hopefully you can see that on above, is recorded by the Department of Analytical Biosciences at Leiden University and presents another quite startling example of rhythm permeating life. Believe it or not, all living organisms emit light. The term accepted by Western science to talk about this light source or energy is biophotons. Biophotons are also known as ultra-weak photon emissions, or UPE, and these are particles of light that are emitted by living tissues, and they're thought to be a form of cell-to-cell communication. They lie in the visible light range at around 450 to 550 nanometers, and yet their intensity of light is 1,000 times lower than the sensitivity of the naked human eye. Lab devices, such as custom-built photomultiplier tubes, or PMT for short, employ highly sensitive CCD cameras to detect and measure individual photons of light emitted through the skin, such as a light emission shown here, which emerge from the back of a pair of hands. This biophotonic research actually relates to a broader tradition of investigating so-called auras. Pioneered by Soviet scientists in the 30s and 40s, Kirlian photography, which should be shown in the image there it is, was based on electrography, or obtaining an image by placing an object onto a photographic plate and connecting it to a high voltage source. In the 60s and 70s, the work of these so-called spirit photographers, which was also known as thoughtography, became linked to parapsychology research in the US and ultimately became heavily criticized and later abandoned as a pseudoscience. Biophotonics today is deemed a promising area of research with the potential for innovative new non-invasive diagnostic tools for healthcare. So why this is interesting is that in a way these kind of light pulses, or these rhythms of bioinformation, for want of a better way of putting it, that are emitted by the body are illustrative of the interconnectedness of bodily processes. As Musim and Ventura state in the quote that should be there but isn't, a substantial body of research demonstrates the interconnectedness of mind and emotion, brain and heart rhythms, illustrating the notion that rhythms can communicate bioinformation that govern a wide variety of functions, including guiding living beings towards health and well-being. So the rhythmical or musical qualities of photons then are perhaps an apt metaphor to describe the communication that takes place amongst cells and bacteria within the human body. The ability to hear and feel the punctuations in rhythms presents an alternative means by which to interpret bodily data, giving physical form to digital information, making bits directly manipulable and perceptible. Back in 2015, in collaboration with artist Dave Young, as well as a team from the Department of Analytical Biosciences at Leiden University, we developed this project you see here called The Rhythm of Life, a hybrid artwork designed to translate the seemingly invisible light energy into something perceivable, something sensible. Employing this photon multiplier tube at its center, that's the kind of two brass tubes coming out of the plastic box, the instrument enabled an intimate experience of biological data, sensing the rhythms of our bodies played directly back to us in real time. So we created this instrument that employed this highly sensitive lab device at its center, and this instrument enabled an intimate experience of biological data. It effectively allowed us to sense the rhythms of our cells and our bodies played directly back to us in real time. And yet, conversely, by performing this personal biophotonic emissions, the experience of interacting with this equipment brings to question the extent to which we start to sense ourselves within data, interrogating the ways in which we attribute meaning and value to legitimize biological information. So, noting the communicative or perceptible nature of biophotons, we might similarly think about smell molecules. For example, those light enough to evaporate and reach our noses, and we might define odors as sense data, essentially, encoding daily practices and shaping memories and identities. This is because odors themselves become spaces for the establishment of not just physical, but also abstract relationships. And these relationships extend beyond different places to the associations we establish and the meanings we create. For decades, scientists believed that the characteristic smell of a molecule was actually written into its shape and how it fits inside the olfactory receptors in the nose, the so-called lock and key theory. There is, however, a problem with this theory, as there appears to be no connection between the shape and smell itself. In fact, the fragrance industry can't predict the smell of a molecule before it's made. They actually need to create thousands of molecules before they actually hit the right olfactory note. Molecules are made of atoms that are connected by bonds, with the arrangement of these atoms and bonds defining the vibration of the molecule. And using a spectroscope, chemists are able to identify molecules by these vibrations. Back in 1995, there was a scientific paper released by biophysicist Luca Turin, who revived the long-abandoned theory called the vibration theory of olfaction, the theory that molecular vibrations, rather than the molecule's shape, gave the substances their distinct smell. In the BBC Horizons documentary, A Code in the Nose, Turin presents the riddle of the carbone molecule that you see here, two molecules of the same composition, but a mirror image of one another. Peculiarly, the molecules share the same number of vibrations and the same composition, yet one smells of mint, the other smells of caraway.
The mint carbone, you don't smell the carbon-oxygen vibration because the molecule sits in the wrong orientation in the receptor. So the prediction from this is that if I added back that vibration to the mint carbone, I should get the caraway smell.
So what I needed was a molecule that would supply the missing vibration at 1800. And I looked around, and several molecules have that vibration, among which acetone, which is really a nail varnish remover, and other analogs of acetone like butanone and pentanone, which also smells like nail varnish remover, is the one I eventually settled on. So what I did was to add increasing amounts of pentanone to the mint carbone until, at a particular proportion, 3:2 in this case, I got a very distinctive caraway smell.
So for years since this theory, it's actually been considered somewhat outlandish. It turns out that there aren't many examples of where this really applies. And that's despite physicists actually confirming that the mechanism behind this, in theory, works. But recent studies actually started to show that by changing the way that a molecule vibrates on the nanoscale actually changes its subsequent smell. So why is this interesting, I guess you're asking? Well, I think what the vibration theory of olfaction actually presents is a quite notable example of how changes on the nanoscale have profound implications for the way in which we as humans experience the world around us. Another pretty fascinating example of this, certainly one of the most thought-provoking, came with another paper from 2015, which determined that the human body is encircled by trillions of airborne bacteria, yeast, cells, and cell parts. That's right, we're covered by clouds of skin and fart bacteria, completely unique to me and you as individuals. And in recent years, we've heard a lot about the importance of the gut microbiome and how the microbiota within actually breaks down food, fights disease, controls your hunger, and by extension has an impact on your mood and behavior. But this was actually the first time that we had compelling evidence that the outer body too has its own microbiome. In the 2010 book Vibrant Matter, Jane Bennett inflects Deleuze and Guattari's notion of assemblage to recognize the active participation of non-human forces in every event and every stabilization. In Bennett's idea, there's never a moment when human agency was anything other than an interfolding network of humanity and non-humanity. So by this logic, all things, including edibles, commodities, storms, and metals, act as quasi-agents with their own trajectories, potentials, and tendencies. So what Bennett and the microbial cloud concept both articulate is a reimagining of the boundaries and interconnectedness of the human body, where the idea of the self is not only determined by the matter that makes up the physical body, but the things and spaces that surround, permeate, and extend beyond us. So if we start to consider rhythms or vibrations then as being almost like an expression of matter, what other expressions might demonstrate the interfolding network of humanity and non-humanity? So, in October 2017, you might have heard in the news the story about the 130-ton monster of Whitechapel. This was wrestled from the bowels of East London. There we go again. Yeah, okay. This fatberg, which is a congealed mass of fat, wet wipes and nappies, was reported to stretch the length of 2 football pitches, taking workmen armed with shovels and high-water powered jets 3 weeks of round-the-clock work to extract. Acquiring a chunk of this for the Museum of London, Alex Werner, the lead curator, noted that the fatberg calls to attention the way that we live our lives in a modern city. Indeed, in the Channel 4 programme, Fatberg Autopsy Secrets of the Sewer, which is a great watch, you should check that out, they analysed a chunk of sewer fatberg and actually revealed the presence of alarming quantities of weight loss products and sports supplements, including Ostarine, which is a steroid, or an alternative to steroid, which is on the World Anti-Doping Agency's prohibited list. Rather than being a symptom of contemporary living then, perhaps it's actually time we address the cause of the blockage itself. Fat. Perhaps the iconic substance of our time. It relates to health, it relates to beauty, ecology and consumption. Fat performs both a unique and vital function as an energy reserve, stored inside the body for times of scarcity. And yet from a Western perspective, fat has seemingly lost this function. In 2005, the global adult biomass hit approximately 287 million metric tons, 15 million metric tons of this being caused by an overweight global population. Fat is stored and stored some more, but rarely used for its original purpose. We just get fatter. But rather than heightening the already quite negative, the negativity surrounding this actually quite important life-enabling material, perhaps we might instead ask, what is fat if its behavior becomes so unpredictable, overtaking not only our bodies but our man-made systems? Do we actually understand this substance in the way that we think we do, or do we require a fresh perspective? This question is actually pretty much at the center of an ongoing project by myself and artist Arne Hendricks, where we build an island of fat, yes that's correct, an island of fat, in NDSM in Amsterdam Noord, as a way to give this material a physical presence, to confront society with fat as substance, calling to question what is this material, what does it want, and what might it yet become. But to go back to looking at fatbergs and sewer systems, as I have to say weirdly it sounds like I was lucky to do myself, seeing a fatberg up close what you actually start to see is a mysterious substance that expresses its materiality through quite surprising transformations. In the middle there you see this kind of very odd foot-thick spongy carpet. On the right, chunks of fat as hard as limestone that when you take pieces and rub them together they break apart. And on the left, a thriving ecology of unimaginable quantities of worms, moths, flies, all feasting on its rich nutritional value. A substance that's effectively going through transformation, a substance reborn. So by focusing attention on the micro-interactions and manifestations that comprise our reading of this material, we might upend our prejudices and expectations to better understand this substance and, by extension, ourselves. So, to end with, a significant influence on my own work of late, and in a way like the approach that I've taken to OpenSet, is the work of writer and performance artist Alan Kaproff. In Kaprov's view, life's subject matter is almost too familiar to grasp, and life's format's not familiar enough. So by conducting life consciously, everyday actions and activities appear strange, with life revealed simultaneously artificial and real. Happenings, as Kaproff came to call these single-performance participatory activities, prompted experimentation with the everyday. Ordinary activities and routine behaviours, such as arranging meetups to trade handfuls of straw, or inviting people to build a series of walled structures from blocks of ice, like you see here, were posited as participatory experiences. Happenings engaged individuals' bodies and minds in actions that transform art into experience and aesthetics into meaning. Participation in such activities was thus fundamental to creating meaningful, transformative experiences. Kaproff importantly came to believe that it was the collective experience of making work and the resulting displacement of the ordinary that caused meaning to emerge, not from the enactment of high drama, but from the low drama of enactment. Happenings then perhaps provide a useful blueprint for the exploration of rhythms, whereby doing life consciously defines settings through which to reveal and harness the interactions and transactions that define the urban fabric. A good example of this from this year's OpenSet programme is the work of artist Heather Barnett. Heather's practice engages with natural phenomena and complex systems. Working with single-cell organisms such as slime molds, complex behaviour emerges from the seemingly simplest of elements, demonstrating collective behaviour, distributed knowledge, and most pertinently, non-human intelligence that enable us to reflect upon the ways that we as humans observe, understand, and influence the world around us. Similarly, designer artist Pei Yin Ling, by exploring the process of fermentation within Surinamese and Nigerian cuisine, exposes humans as dynamic biological assemblages, investigating the ways in which biological beings, including humans, migrate, connect, and transform on a microscopic and macroscopic level. What I believe these and all the other invited practitioners convey is a shared ethos of zooming in on the minutiae of life to defamiliarize and thus reconfigure understandings of the complex rhythms and relations that constitute the conception of neighbourhood. I'm excited to see how this year's research programme unfolds. Thank you very much.
Thank you. Thank you very much, Mike. Like combining already so many